But if it's something in a liquid, it will become more concentrated over time. Okay, this is really important. That pen is not. An anion that is the conjugate base of a strong acid will not affect the pH. I've already said this multiple times. So the anion of a conjugate base, sorry, that is a conjugate base of a strong acid will not affect pH. That would be something, well, we've used it a lot, like Cl minus. Cl minus in solution does not grab the H plus to make the acid. It stays completely dissociated. So if Cl minus does not mess with the concentration of H plus, then it will not affect the pH, because affecting pH means you're changing the H plus. It will not. If it is something that is strong, it definitely does not affect it. So, Br minus, like NO3, all those three things, if we add them, it does not have an effect. And what I mean by this, I'll come back to this slide in a minute, but what we're doing now, and this will set us up a lot for chapter 17. I'll go back, whoever said, oh shoot. Oh, okay, we have water, and now we're not adding an acid or base, we're adding a salt. So like if I added NaCl, what this is saying is adding NaCl to become Na plus and Cl minus has no effect on the concentration of H plus or OH minus. So even though we've added things to it, the pH will stay the same. And that is because both of these are the conjugates of strong things. Good enough? Yep. So NaOH, that would be, Na plus would be the conjugate acid of a very strong base, and vice versa. Okay. Oh, you're all right. All right. An anion that is the conjugate base of a weak acid will increase the pH. I'll show you in a minute. The reverse will be favored. Whew. All right, so let me draw this one out. So what I'm about to draw on the next page out is that second bullet. So we know vinegar, acetic acid, is weak, right? It has the acetate ion, which is C2H3O2 minus. What the? I wrote minus one, I guess. Maybe that's where my brain went. This is the conjugate of a weak acid, right? So what that means is if I have HC2H3O2 and it has this, it goes to H plus C2H3O2 minus. If it is weak, it means that this side is favored. So follow my logic here. I have my beaker. It's got just water. And then I dump in some sodium acetate. We know that's extremely soluble, right? So we're going to add in sodium. Okay, it doesn't want to write right there. It doesn't want to write there. We have Na plus, and then we have the acetate. I did it again. Right. Oh my, I want to punch that, but you kind of get the idea, right? Which side of this is favored? this side, right? So what will this do to any available H plus in the solution? It'll bond to it. All right. So that means that we cause a decrease in H plus. A decrease in H plus means an increase in what? pH, because the OH is now in greater concentration than the H plus. What's that? The Na plus would have nothing to do with this. Is Na plus in this thing at all? In the solution, we are talking about the conjugate base right now. This thing. Sodium is the conjugate acid of a strong base, so it will not affect. That was the top slide, or the top of the 3 bullets. The acetate grabs H's, so its concentration decreases, which means the pH increases. Fabian, was that you that raised a hand? You were just doing your hair. Oh, something got me over there. Okay, sort of all right with this. So it's kind of interesting. I can have just plain water and I can make it acidic without adding an acid or a base. I can add the conjugate of something that's weak and let chemistry make it an acid or a base. And we're going to do that a ton in chapter 16. It's attached to something else. Like I could go in the back room right now and just grab some crystalline sodium acetate. Like it's a thing that's been manufactured, and I can grab it. Okay, coming here.
Wait, we're not gonna make it more basic.
No, or yes. Right, that's what we mean by an increase in pH. It becomes more basic. All right, a cation that is the conjugate acid of a weak base will decrease the pH. Okay, so a weak base would be something like aluminum hydroxide. Since this is weak, we'll put it all together on another slide. Since this is weak, it's the same explanation. Let me make this a little bit thicker. Oh, that one. All right, so AlOH3 goes to Al plus 3 plus 3OH minus. You with me on that one? Since this is weak, which side is favored? This side, correct? Okay, so we'll do the same type of chemistry. Coming along here, we would say, all right, I have my beaker that's just full of water. And then I add something that I know will dissociate. So AlCl3. You okay with that? I dump this in, and I know this dissociates because I have chapter 4 memorized, stone cold. Right? All right. So I have Al, and that's a plus 3, and whatever, that's a 3. And I have my Cl minus. One of those two I couldn't care less about. Which one is it? The Cl minus I don't worry about because it's the conjugate of something strong. So I now think, all right, I have this ion in water. Where's it going to go? It's going to go that way. In order to go this way, in my mind, that arrow was going to look pretty cool. It really was. You're going to be like, wow, Davidson's so amazing. Let me try this again.
Oh, it's going to be like a connector.
Yeah, whatever. It's terrible. Don't worry about it. It's going to go that direction. In order to go this way, what does it have to consume? OH, which means we have the H plus concentration increasing based on Le Chatelier's principle. which means a decrease in pH. I know that's a lot of like, hey, that's going to increase because that's going to make that decrease and the pH is going to decrease. And you're like, well, I hate this class even more. All right, well, remember, you chose it, not me. I gave all my AP classes the same lecture today. Or sorry, my chemistry. Anyone want to guess what that lecture was? Don't take AP.
Because my AP class sucks.
No, I said because you don't want to work as hard as you're going to need to. Not you. That's what I told them.
Yeah, why did that come from my mouth? Well, I'm just saying, like, I feel like don't you kind of see something?
I would never bag on this class.
Okay.
What?
I know you do. David said I've heard so many things in the other class about. I know you do.
Well, tell me they're not true.
Okay, I guess I don't have proof. I don't actually.
I'll wait. Okay, here we go.
I feel like Nisha, Caitlin, and Grace were very hard. What do you think?
I would add 2 other people to that list, but I won't name them. Okay, here we go.
Wait, what?
The list of people who are working hard every day. Okay, tell your lab partner why sodium nitrate did not affect the pH of this. Ready, go.
Wait, because it doesn't affect it?
It does not.
Because it's extremely base. Oh, no, it's not a strong acid.
Yeah, exactly. Hey, Murray, I'm not adding HNO3. I'm adding NaNO3.
Yeah, and NO3 is an anion of a strong acid. I'm looking at my notes. I just didn't remember HNO3 was a strong acid. That was my first.
All right, here you go. Why doesn't it affect it? All right, because both ions, so Na plus, and if I had HNO3, right? Like turn them into their acids and bases and then check, are these both strong? Yes, strong means they don't come together, remember? Strong means they stay apart. So adding Na and NO3 does not either form this or that because they stay apart. So the H plus, thank you, Judah. The H plus is not affected, nor is the HOH. All right, now from here, we have calcium nitrate. That made it 6.9. That's not very much, but it's a little. That would mean that calcium nitrate or calcium hydroxide it's not very weak, but it is sort of a weak base. It had, right? And I know it seems weird, it became more acidic because it made a weak base, but that's how life rolls. It's taking away the OH and tying it here. All right, and then we'd say zinc, it is a weak, and then aluminum, it's the weakest, like its conjugate, AlOH3. Yep, I'm not sure what this one would be, but yeah, just some indicator they dropped in there, and then they added different amounts, and we got what it was. All right. All of these caused, well, this one did nothing, but then yes, those 3 caused a decrease in pH. I mean that the base I could form, that cation is the weakest. So if we ranked them in order of strongest to weakest, we would have NaOH, then we'd have CaOH2, then we'd have ZnOH2, and we'd have aluminum OH3. And we could rank them in that order because this one had the greatest effect on pH, which means this one is the most likely to come together instead of break apart. This one had no effect, so it's 100% going to be separate. You're welcome. Okay, I think,
But it's the strongest conjugate acid.
yep, yep. Okay, we have to just do this real fast because we spend so many hours on weak. We just need to do one strong. What is the pH of a 0.015 molar solution of nitric acid? And this is where smart kids, they like wreck the car because they're like, it doesn't give me a Ka.
Because
Drive it off the cliff.
Yeah, like I don't know what to do. I'm so used to Ka, Ka, Ka. No,
yeah, it's like it does.
it doesn't have a Ka.
Oh, I don't have pH.
I was so used to not putting on the part at the very end, that last point. I always forget.
Dang it. No, no. This requires a calculator. You're going to want to punch yourselves.
Probably, yeah.
Okay.
Okay. Okay.
Nitric acid,
Yep.
like really strong.
Very.
Okay. Yeah, it seems to.
It should be extremely easy.
I think I got it.
Yes,
I was like, this can't be that easy. Yes, sir.
You will. It's super easy. You're just used to hard things, so easy things don't feel right.
That makes
Okay.
me so upset.
Okay, look at me. Nitric acid is strong, which means HNO3 completely dissociates into H plus and NO3, 100%, right? So if I had 0.015 of this and it dissociates completely, that means I have 0.015 of H plus who cares? So what do I do if I know the concentration of H plus to find pH? Take the negative log.
Oh, so that's still the same, even between strong and it's always.
Well, as long as you know the H plus, you're always ready to roll. Whether it came from what calculation I found it, it matters not. Once I know H plus, I'm ready to roll. So everybody, to find the pH of a strong acid, you just take the negative log of the concentration. To find the pH of a strong base, you take the negative log of the concentration and subtract that answer from 14. You okay with that? Okay. Oh, that's the same one. Why is that there? I think this is the last slide. Nope. Okay, it's the last concept. Okay, well, wow, I thought we were way closer. We're still like within 5 minutes. Okay, factors that affect the acid strength. This is, as you can read there, it's in your reading. So the more polar the bond and the weaker the HX bond, the more acidic the compound. Acidity increases from left to right across a row and from top to bottom in a group. So what this means is when you have your base that involves something here, it's much more basic than something here or here. And we just had the data. We just lined those up a minute ago and said NaOH was way strong and aluminum wasn't. So the more left you are, the more basic the base, and the more right you are, the more acidic the acid. Now, those are general statements. There are definitely exceptions. The main one being, yeah, the main one being HF. No, well, it's like that where there's trends. Yep, that's chapter 7, but this one you just read it at the end of chapter 16. What's that? Because F is extremely good at holding on to what it already has. So it's the hottest one. So it's still reactive, but it holds on to F a lot, or sorry, H a lot stronger than water attracts H. All right. In oxy acids in which an OH is bonded to another atom, Y, the more electronegative Y is, the more acidic the acid. So you're like, what does that mean? And these are not really tested, but I'm just reading it to you. An oxy anion, if you have the more polar the substance is that's with O, the smaller the Ka. So that's why when we listed the strong acids, we listed the HClOs, but we didn't the HBROs or HIOs because they're not. So just, I don't know.
So the more polar, the stronger it is. Unless it's hydrochloric acid.
That's a good way to look at it. I don't know. There we go. That's pretty easy just to summarize here. For a series of oxy acids, acidity increases with the number of oxygens. So the example here is we have HClO, HClO2, LO3, LO4. HClO4 is the strongest. Next, and then we're to weak. So the more oxygens, the more acidic it becomes. Time we out, Grace.
Is that because it holds, yes,
Okay,
is that because
perfect.
it holds one of the H's away and makes an H plus solution?
On half of them, yes. But I don't know. This is not tested at all, but a resonance structure, resonance in the conjugate base of carboxylic acid stabilize the base and make the conjugate acid more acidic. I'm not going to spend 2 seconds on that. Okay, this is the last thing. A Lewis acid and a Lewis base, they're not that bad. Lewis acids are defined as electron pair acceptors. So we had Bronsted-Lowry. We had, what was the other one? No, I can't believe I've forgotten this term. Arrhenius, thank you. And now we have Lewis. Oh, this is a different type of acid. It doesn't really matter though. The only thing we switch is that Lewis acids are defined as electron pair acceptors. Atoms with an empty valence orbital can be Lewis acids. So it's very bizarre here, and it's very uncommon. But you may remember a long time ago that boron trifluoride violated the octet rule and left a space that a pair of electrons could reside. If it can accept a pair, it's defined. It's another thing that's defined as a Lewis acid. Now, not every acid is a Lewis acid. Okay, then a Lewis base, they are electron pair donors. Now here, anything that could be a Bronsted-Lowry base is a Lewis base. Lewis bases can interact with things other than protons, however. Don't stress a ton on this. Nope. Like you need to know the term probably, but not a ton. Okay, 30, that's what you said, correct? Okay. Take out a piece of paper. You're going to turn this in 8 minutes. Yep, shut all your notes, take a piece of paper out. Oh, it's like rip it out because you're going to hand it to me. Oh,
We're watching a video on cooking out.
all right. I want you to see, I want you to do this problem and then I'm going to grade it. And if you rock it, I'm not going to make you take the test tomorrow. Do I sound serious? Okay, good. This was a good idea I thought I had. You cannot have your notes out. You cannot discuss it with your friends. This is a pre-test test that you can get out of a test. So we're going to call it a test. I enjoyed saying test 4 times in one sentence. Focus, you only have 6 more minutes to do this problem. He said, it looks like I'm taking the test. I'm an idiot. Sorry, Davidson. Don't waste your time. You have 6 minutes.
What is
Yeah, you have to finish before you leave.